Next, let's talk about the HTBC4 Transformer Ratio Tester. It mainly measures the three-phase transformer ratio. There are many kinds of transformer connection methods that it can measure, such as triangle, star, and Z-shape. Of course, a single circuit can also be measured. It has two sets of test lines. We must first note that the test line marked red on the instrument panel is used on the high voltage side. The black wire is used on the low voltage side. The red test lines, yellow, green, and red, are connected to the corresponding three phases of A, B, and C. Then connect the three test wires clamp at the other end of the yellow, green, and red terminals on the high voltage side of the transformer. Then connect the black test line to the panel of the instrument corresponding to its A, B, and C phases. Similarly, we should clip the three test wires on the other side to the A, B, and C three-phase corresponding to the low voltage side of this transformer. If its secondary side is a star connection like ours, it will have a central zero. This center zero is disconnected. Just leave it blank. Make sure that the connection is not wrong. It must be like this star connection method, which is like three phases of A, B, and C, common zero point, and connection point. Zero is not connected. Don't make a wrong connection. We connect the power supply and start up. Then, let's take a look at the interface. The first is the test settings. The second is to start the test. And the third is data browsing. This is the data browsing of previous tests. The fourth is the system setting of the whole instrument. Let's test the transformer first. After we click OK, the first column is the test number, which means that you may test many different transformers every day according to your requirements. We set a number by ourselves or according to the nameplate of the transformer. This is the wiring method. This D is the triangle. Y is the star. Then our test wiring method is a connection method of high voltage side triangle and low voltage side star. This must be selected according to your requirements. Like this one is the star of high voltage side and the triangle of low voltage side. This is Z-type connection on the high voltage side and triangle connection on the low voltage side. According to the wiring method of the tested product you measured, choose one corresponding to it. Make sure that the method is correct. This one is to set the rated ratio. It is the rated ratio on the nameplate of the transformer you are testing. It is the actual ratio of the high voltage side divided by the low voltage side. If you do not set the rated ratio correctly, the error will be very large and there will be no reference. That's just not right. This one is called tap gear, or switch gear, or tap changer. Because of a transformer, it is called the main transformer. Generally speaking, the main transformer has dozens of gears. A distribution transformer like this one is called power transformer. It also has 3 to 4 gears, and by standard we test each gear. So we can set it up in this place of which gear you measure. which gear you use. It's all slightly different. It can test the actual change ratio under your current transformer state. This is only for you to choose later, that is, to find data or to have a requirement for data record. There is no requirement for the result. This place we call it impedance. Some place is called short circuit impedance. Some place is called impedance voltage. This can be found on your nameplate. For example, the impedance voltage for this transformer should be 4%. Then we will change it and set it according to your nameplate. OK. After the setup is completed, we start, exit, select the next project to start the setup, and then click OK. Then, when the system's default test is finished, it will pop up the results you need. At present, we have chosen 10,000 V for this transformer, 10,000 V for high voltage, and 400 V for low voltage. So, its change ratio is 25. Let's take a look. The transformer we tested has a ratio of 25. Let's see. The result has appeared, corresponding to the three phases of A, B, C. AB, BC, CA. Since it is a triangle connection, it must be one of these results. Then its ratio is 25.015 to 25.018 to 25.021. Then the rated ratio we set was 25, so the error of its ratio was 0.06%, 0.07%, and 0.08%, which was very good. In this case, we can, according to the above, save, set, OK, exit.